excuse me, in mind, let's take a look, kind of remember where we were last time. So I'm throwing this on the screen, kind of just as a overall review of just like what we were just talking about the type of questions that you've seen in GRs up to this point that you'll continue to see, is that because of the close-ended format that the GRs have to take, we don't ask you to calculate as many things on there as much as we give you scenarios or results from scenarios and then ask you questions about it. So it's more incumbent about you to be able to interpret what's going on. And so this is a good example of, one large screen of data that there are a lot of questions that you could be able to answer. Now, if this was presented in a GR, it would probably at least have a preamble of saying something like, hey, the math department is curious about trying to predict future math scores based on a student's history and how much they study. So they've got data where the variable calc is the score that you get on the Calc 3 final. Study is the number of hours that you study in preparation of that test. And level is the highest level of calculus that you have completed at the Air Force Academy. And then based on that intro, there are a lot of questions that I could ask based on this screen of information, right? I could ask something as simple as how many different values does the variable level take on? So if I asked, let me actually ask that. Let's say, Audrey, you online? Yes, no, maybe so. Let's go instead with Brooke. You online, Brooke?
Yes, sir, I am.
All right, so if I were to ask you based on this screen, how many different values does the variable level take on? What would you say?
I would say 3.
Right. Now, here's the follow-up question. The follow-up question is, why are you saying 3? What from this output tells you 3? Because you're definitely right.
If it's not level 2 or level 3, it has to be something else. And I would assume it's level 1.
Right. So the takeaway is that level is a categorical variable, which even if I didn't tell you, you could tell because down here in the output, there's no level variable, but there's level 2 and there's level 3, meaning that R has added 2 indicator variables. And we know that when it's a categorical variable, it always adds enough indicator levels of all but 1, right? And because in here, the level is either equal to 1, 2, or 3 for Calc 1, Calc 2, or Calc 3. So the fact that we see 2 different indicator variables down there for level means that there are 3 possible values. Now, one thing I want to make sure I'm clear, the fact that it says 3 there is not as important, right? Because that's just because the way this variable is stored is it's either equal to 1, 2, or 3. If instead I had said the levels were equal to ALG for algebra, TRIG for trig, and CALC for calc, then down there we'd still only have 2, but it would be something like level trig and level calc to represent the 2 that was showing, and then your answer would still be that there's 3 possible values. You just don't know that the one that's not there is algebra, but you know that there's a reference level that's missing. Other questions I could ask about data like this is I could say, what is my response variable? Well, the response variable is the thing I'm trying to predict, which is always to the left of the tilde, which is calc. I could say, does this Does this model include interaction terms? It does, because we've got this, colon here. I could say, does this model include polynomial terms, or higher degree terms, or maybe quadratic terms? No, because I don't see any of that in here. I don't see poly. I just see study, level 2, level 3, and then these interaction terms. I could ask, what does the regression equation look like? And I could give you several examples of a regression equation, and you should be able to pick out the correct one using this column of estimates, right? Because those are all of the coefficients. Those are literally this number, this number, this number, this number, this number, and this number. And you should be able to look at a list of equations, and based on those, find the one that says 40.729 plus 0.95 times study plus 19.25 times level 2, and so on, right? And find understand that connection of what is going on there. I could also just ask you a straight up numerical question of saying, hey, if I told you what the levels meant, and I said, that they are Calc 1, 2, or 3, and I said, hey, a student is in Calc 1, and they studied 3.7 hours, I could ask you, what is the predicted score that they are going to get on the Calc 3 final? We did some examples of this yesterday, right? But the thing I want to point out is that to answer this question, I only need these two numbers right here, right? Everything else on there doesn't have any. I don't need it for this question. I don't know why I wrote stud instead of study. And so that is a good thing to remember, that a lot of times you will get a question that has a lot of information, but part of the question is deciding which information you need and which you don't, right? This is a student in Calc 1, so I don't need this. That's about a Calc 2, Calc 3, Calc 2, Calc 3. All of this is about the hypothesis test information. And so for this whole screen, I only need those two numbers, right? And so a lot of times I will see people lose points on a GR because there will be some answer that uses all these numbers, and they'll be like, well, I thought it was just this answer, but that's not using all the information they gave me. It's got to be this answer because I have to use all the information. Not true. A lot of times part of the question is deciding what information to use. So don't fall victim to just saying, there's stuff here, I gotta use it, right? All right, any other questions about stuff on an output screen like this that you don't know how to use, or types of questions you've seen that you wouldn't know where to grab the data from, or just something that I said that doesn't make sense with what's on here? All right. Okay, then quick review of what we were talking about yesterday was this idea of transformations, right? Of saying sometimes we get data that when we look at it, and more importantly, when we look at the diagnostic plots, we see that the assumptions like linearity aren't met, but there's clearly a pattern. And so there is a nonlinear relationship. And so we can use transformations to fix some of those assumptions, right? So in this case, when we look at it and go, hey, that looks like a exponential relationship, then I can do a transformation, in this case, a logarithmic transformation on the response variable, saying there's not a linear relationship between the predictor variables and the response variable, but there is a linear relationship between the predictor variables and the log of the response variable. So I can make R find that relationship, and then I can do a back transformation to solve for my response variable and get a nonlinear relationship equation based off of a linear regression on that transformed value. And the thing I want to foot stomp on here is that this can help fix a lot of problems, but it can't fix independence issues, right? Reading some of your guys' labs, oh my gosh, it's snowing. What is wrong with this state? From reading a lot of your labs, there's still this confusion that when we check for independence, a lot of you say it is not independent because the X and Y variables are related. That's not what we're talking about. You're talking about, are the variables independent? But the assumption is, are the observations independent? Which means if I look at one observation in my sample, does it give me information about another observation in my sample, right? So for the example of our Instagram data, it is not independent because some observations in the sample come from the same Instagram user. And so if I know that this Instagram user, I look at one observation and it has 1 million likes, then I have a pretty good idea that another post from them will also have a high number of likes. So the fact that information about one observation gives me possible information about another means they are not independent. And because that is a quality of the sample, doing transformations doesn't change that, because the transformations just mathematically kind of plays with the numbers. It doesn't change my sample. So transformations can't fix an independence problem. The only way to fix independence issues is to change your sample in some way. All right, then we talked about a different kind of transformation. We said, okay, what if I, again, I'm seeing that some of my assumptions in the diagnostic plots are not met, but I'm seeing a relationship here in nonlinear, but now it looks like a polynomial relationship. And we talked about saying, well, we can do a polynomial version of a transformation. But here, instead of doing a transformation on my response variable, I'm basically going to do a transformation on my predictor variable. And that transformation is saying I'm going to add variables to my equation, but they're not going to really be new variables. They're just going to be higher degree versions of my variable. R doesn't know that. It just says one variable is X, another variable is X squared, and it treats those as two different variables and then tries to do a linear regression on them. And you know, as the human, that what it's actually giving you is a polynomial equation, right? And the nice thing about that is we can call that in R using this poly function. And whatever number I put here is how many terms. If I put in 4 there, then it's going to try to regress it based on x, x squared, x cubed, and x to the 4th. And I can do that however many times I want, right? So types of questions you could be expected to answer on something like this is, again, being able to interpret this output, right? You should understand by looking at that output that since the call was to do a regression of the y variable versus the polynomial version of this, that when you read that output, you should know that what that output represents is a regression equation that is y hat equals 952.55 minus 2,320.52 x plus 6,498.4 x squared, because that was the second term, second degree of the poly, right? And that this is the regression equation represented in that output. And then if I asked, hey, what's the predicted y value for an x equals something, you could put in x here and solve it and get an answer. So any question about what the polynomial transformation and fitting is, how we do it in R, and how to interpret that output? All right. Okay. Before we go into a review of or before we go into working on lab 10 together, let's do a quick proof to me that you know what's going on. So what I'm going to do, let me see if I can make something. I'm going to say L, I'm going to go summary L, M, and I'm going to say MT, $, MP, G, tilde, and then I'm going to say poly, let's say horsepower to do. Okay, so let's try this. In R actually has a few data sets that are just built in R. You don't have to import them at all. And one of them is a data set called MT cars. That's just a data set about some general car information. It includes variables for miles per gallon, cylinder, displacement, horsepower, weight, some things like that, right? So you guys can access that data set if you were to do, so I would try doing summary of MT cars, and you can see what all the different variables are in there. And so what I would like you guys to do is one of the variables is displacement, and one of the variables is horsepower. And so what I would like you guys to do is I would like you to try to I would like you to build a model using displacement and horsepower, and I would like you to do it using a second degree polynomial on let's say a second degree polynomial on horsepower. On horsepower, and just a linear on this. So what I would love you to do to try to predict miles per gallon. So what I would like you guys to try to do is generate this regression equation. I'm going to call it beta displacement times disp plus beta hat of horsepower 1 of horsepower plus beta hat horsepower 2 of horsepower squared. So this is the regression equation I would like you guys to try to build. And so if you guys can do that and tell me what these coefficients are and drop them into the chat, that's what I would like to see to prove that we understand what's going on. If you get stuck at any point on this, then please let me know and I will help you as needed. So I will say up here,
should we find the data for the cars in the lab 10 thing? Is it just named something different than MT cars?
You can just, you shouldn't have to do anything. MT cars is already in R. If you just wrote summary MT cars at a blank R prompt, it would give you the data as if it's already imported. It's part of base R. So if you say summary MT cars, it'll show all the variables. If you said MT cars $HP, that will be accessing the horsepower. So you shouldn't have to import anything, unless I'm missing your question.
No, sir. That answered it.
Gotcha. And like I said, do not beat your head on this too hard. Like, figure it out. But if you don't know where to start, just tell me you don't know where to start, or that you are trying to figure out what code in here. Because the point is here is to help you understand how to use these. And if you need to flip back a screen to see something, or you need a starter, let me know. Don't just sit here and go, okay, well, I'll just wait until all the answers go and I will maybe understand it someday. If you don't understand, let me know. That's why I'm here. Also, while you guys are working on this, and interrupt me if you need to, as a reminder, we have class on Friday, and that is a review. So please send me any questions you have before then, and I'm happy to bring them and work on them. And then on Tuesday and Wednesday of next week is our GR. So we will not be meeting, but you guys will be taking that online. On Friday, I am going to be looks like I'm going to be with the track team in Fresno. So I will be teaching class normally and doing the review. I'll just have a Fresno hotel room in the background instead of my office. Let's see. Model equals LM, miles per gallon, tilde disp. That looks awesome, Devin. That seems correct to me.
All right. Thank you, sir.
Actually, yours is even better than mine because I did mine with a bunch of dollar signs, and so it looked a lot messier. But yours with the just doing everything without the dollar signs and then just doing data equals MT cars, that's a much nicer way of writing that. Also, guys, why is it snowing outside? It's freaking almost the end of April. I am planning on trying to have some outdoor barbecues and movie nights, and I did just, if the state could get it together and make a decision. I don't even care if it's going to be winter or summer. I just needed to choose.
Sir, I will say it will be a high of 80 this Saturday.
Which is great, but that's almost worse. It's like snow today, 80 this weekend. Like, it makes it very hard for me to teach you guys that statistics are reliable when there's variation going this far up and down in the state. So let me just say, statistics and probability are great, except apparently in the state of Colorado and weather. All bets are off there. But for the rest of the world, it does work, I promise.
Follow-up question: will you be throwing it down on the grill this Saturday, sir?
Well, I'm going to be. I'm leaving. Like I said, I'm going with the track team to Fresno, and they said I'm coming back by Saturday afternoon. So I should be able to throw down on the grill there. The problem is my mother-in-law is here. She does not eat as much, and my wife is still recovering from surgery. So it's just me and my kids. But that being said, I have 2 teenage sons, and so between the 3 of us, we can pretty much do a grill full just between us. So even if everyone else is out, we'll probably be doing that. I've got a We usually try to do a variety for everyone. It was a very eclectic mix on the grill last time we did it because it went from Impossible Burger from my mother-in-law, some marinated chicken breasts for my wife, and then for me and my sons, it went the other direction where and don't judge us, but we literally had pull sausages that we split down the middle and then put a cheese stick in the middle and then split that cheese stick and then put a slice of bacon in it. And that was our Richard's dogs that we made to have. So I don't know if that sounds awesome or horrifying to you, but they tasted great.
That seems pretty scary, sir.
Yeah. Okay, I'm not seeing any responses. I would, like I said, if you guys have a screenshot or just want to give me those betas, using what Devin has up there shouldn't be too hard. The only final that should spit out the summary. All you need to do is be able to interpret the results and give me back the equation. So is anyone struggling to get it created, or is anyone struggling with interpreting the results, or did everyone just forget that I actually wanted you guys to give me those beta estimates? You don't have to give them all to me. Give me one. Give me what the estimate for beta naught is. Give me what the estimate for the second degree term of horsepower is.
I got a beta naught of 37.35 approximately.
37.35. Okay. I did not get that, but that does not mean that you were wrong. It is possible that I did something wrong. So let me see what we got. So we are trying to do miles per gallon using displacement and a second degree polynomial of horsepower. So here, let's cut to the chase and say here's my results at the bottom. So you guys tell me, what did I do? Why am I getting a different beta naught than you guys? Is this just a different data? It's possible maybe I don't understand this data set and it creates some random stuff. And so you guys look at my results here and tell me either why I am wrong, or if it looks the same as yours, but I just have different numbers and maybe I just misunderstand what R is doing.
I got the same thing, sir. Same numbers as you.
All right, well then what did we do different? Matt, what do you got? What's going on here that I did differently than you, or vice versa?
I went with the method of creating an HP2 variable that was just the square of HP and added that as a variable.
Oh, so you created your own, you took the HP variable and made a new variable that was the square of that and then regressed it based on that?
I did.
Interesting. And you got different results.
Yes. It looks like
So
Steve got the same results as me.
And did you do the same thing, Stu?
No, sir. I actually, like, after looking at Devin Schwint's answer, my code is exactly the same as his.
And you got the so let's do the same. So what we'll do is let me run his. This may be and indulge me here for a second. I just want to make sure. Yeah, so when I do it the two different ways here, it looks like I'm getting the same answer. I just copied and pasted Devin's in here. So it's unless you, if you guys are getting the exact same things, then perhaps the data set is slightly changed across R. But that looks like I'm getting the same response. So as long as you guys are getting similar answers, it looks like the it looks like our the slope of our displacement is exactly the same, but our intercept and horsepower are off, telling me that maybe that data in our data set is slightly off. I'm not sure. Does anyone go ahead? What do you got, Steve?
Sir, I just plugged in Devin Schwint's code into mine, and it gave me the same answer as yours, but I don't know what I'm doing different. Like, the only thing that I can see is raw is equal to T. And is that like something that I shouldn't be doing?
What is because you said that is, I've never used that raw argument before. I'll be completely honest. I don't know what that function does. What does the raw argument mean? Do you know?
I was just following the video, like their example.
Okay. Well, then I will have to look into that. But I think both of these look relatively legitimate. I just got to figure out what is the. It seems like it is a difference in how it is being calculated. If I say.
So I took out the raw is equal to T thing, and I got the exact same value as you guys. I just don't know what raw is equal to T. Like,
Well, let's find out. So if I go over here and I say raw, if true, use raw and not orthogonal polynomials. I'm not going to pretend I'm smarter than I am, guys. I don't know what that means. I've never used that. So I am going to, for the purposes of our work, I would just ignore that raw, but I'll have to follow up with instructors who are smarter than me to find out what the difference between raw and orthogonal polynomials are. But it seems like it is a difference in how it's assessing. So I would just leave. I've always left that term out, so I would leave that raw, but that's something I'll have to get smarter on and let you guys know later. Okay, we got about 10 minutes left. So if you have any questions on what we were just doing and how to interpret it and how to work it, please take the time to ask me that in our last 10 minutes here. Otherwise, what I would ask you guys to do is to use this last 10 minutes to open up and start working on Lab 10. I say start working. Hopefully you are already working on it. So at a minimum, open it up and go through it and either work on it now or just take this 10 minutes to read through some of these questions while we are here together. So if you come across something that you don't understand what it's asking, that you can ask me now for clarification so that you can work more on it on your own later. A couple of things about this, if you haven't looked through it all, there are a lot of questions on here, but don't get scared about that. A lot of the questions are make a plot. What does the plot say? Make a plot. What does the plot say, right? So there's a lot of kind of quick one-offs on here. So don't think that this is going to be 2 weeks of work. It should not be that bad. Another question that's come up several times is there are 2 data sets associated with this on Teams, InstaTrain and InstaTest. You are going to use InstaTrain for almost all of the questions on here. You only need InstaTest once you get all the way down to the bottom on question 31. It says use the InstaTest set as a small set to test the work you've done. So you're going to use InstaTrain for everything, and then InstaTest is only needed for that last question 31. And then the last part is a couple of people have run into a problem with their version of R giving them an error on one of the questions. And it turns out it's because of the way R handles special characters like a tilde or an umlaut or things like that. So I got to post put something up on the all students channel, but I will tell you guys just for your own edification right now, so you have it. I'm posting it into the chat right now, is a updated version of InstaTrain that has all of these special characters stripped out. And so that if you run into that problem, that should solve that problem. But I'll put that on the all students. Okay, get to it. Let me know if you got any questions on transformations, what we're talking about today, the Lab 10, or like I said, as always, please, 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 if you got any input on how to make the tests of the labs better, what you like or what you absolutely hate about them, send me messages on it, or at a minimum at the end of the semester, take 10 minutes and give me some feedback, because I really want to make this course better, and it's been a long struggle. And moving back into the classroom, I'm hoping that will solve a lot of the problems and we'll be able to work more, but I want to take advantage of it, not just do this course in a classroom. I want to take advantage of it in the classroom and figure out what's the best way to do that. I don't know what this is, guys. I might be going to jail. All right, well, if OSI bursts through my door, you just let someone know.